Good morning, ladies and gentlemen. Let me introduce myself. My name is Anggina Sundari from Universitas Pancasila. Today, I will present my paper with title Quality Control Analysis of Tube Sandwich using Six Sigma Method in Cement Company. Quality improving of the product is a must for companies that want to maintain their existence. Quality products are not only determined by high quality of raw material and reliable production process, but also the quality of product packaging. Like opinion from Director General of Indonesia Ministry of Industry, the quality standard of packaging has a very important function. In addition to functioning to contain or wrap the product, it can also be means of promotion and information of the product while enhancing the image, selling power, and competitiveness. Paper bag division is a division that produces and provides all types of bag cement for this company. For your information, ABC division has three types of machine used to produce cement bags, i.e. bottomer, sewing, and tubbing. The highest proportion of reject product every month in the production of tube sandwich it will affect the cost incurred the production floor. From December 2019 until February 2019, TM1 had a reject proportion of 0.63%. It means the reject proportion is higher than company reject standard, i.e. 0.40%. Some action and effort are needed to reduce the high proportion or reject on TM1. Identify the cause of the most dominant problem, then analyzing and providing solution for improvement the problem. Therefore, we are interested in conducting research using Six Sigma method to reduce the high proportion of reject that occur in TM1. Method Six Sigma is a method for increasing productivity and profitability. In addition, Six Sigma is an application of statistical tools to identify, measure, and analyze the defect or waste of a product and process, so it leads to step for improvement. The phases of implementing quality improvement with Six Sigma consists of 5 phases. Define the purpose of this phase is to set the foundation for the work ahead in solving a problem. Measure. After completing this phase, we expect to have a plan for collecting data that specify the data type and collection technique. Analyze. This phase can be done by formulating some of the biggest causes of the problems so that the next phase become more focused. Statistical analysis-based thinking plays a very important role at this phase. Next, improve aims to generate idea, design, pilot, and implement improvements. And the last, control phase, is the place where the transition from improvement to controlling the process and ensuring that the new improvement takes place. But in this study, we only discuss up to improve phase. In this phase consists of 3 activities, i.e. identify the types of defect, determine CT key, determine the most dominant type of defect. The types of defect are determined based on reference from the product check sheet as well interview the related staff where found 6 types of defect. There are gluing, printing, mismatched size, paper extension, overlapping, and the number of plies are not appropriate. Strategy determination is based on sample data taken by observing in the form or of random sampling of 25 samples with a sample size of 560 pieces. From sample that has been collected, the most dominant type of defect can be determined by making a Pareto diagrams. According to 80 80-20 rules. This study will more focus on analyzing the types of defect caused by gluing and printing. In this phase consists of two activities, i.e. create P control chart and calculate the TPMO to find out the sigma level. All sample points are within the control limit, however, there are 13 sample points above the central line, which in this case is the standard set by the company. Therefore, further analysis is needed. DPMO value obtained from the production process on tubbing machine equal to 3691. The achievement of sigma value is 4.18. Even though the achievement of the sigma values is above average, there must always be continuous improvement to achieve the Six Sigma target. In analyze phase consists of three activities, i.e. analyze the cause of defect with the fishbone diagram, determine failure modes with CFME, and determine the problem priority with FMEA. Pareto diagrams show the dominant problem caused by the type of defect caused by gluing and printing problems. The further analysis of these two problems using fishbone diagrams is given on this picture. From fishbone diagrams can be found three factors causing defect: machine, method, and material. CFME aims to clearly the root cause of the problem. First branch is obtained from fishbone result, while the last branch will be used as a failure mode in the FME method. This is a result of the FMEA method for defect caused by gluing and printing. The highest RPM to reject gluing was 336 from machine factor, and the highest RPM to reject printing was 294 from method factor. From the Colin table has been selected 5 failure mode for gluing defect and 4 failure mode for printing defect. Proposed improvement can be seen in the following slide. This is to repair gluing defect, and this is to repair printing defects. And the last slide is conclusion. Suggestion and action that can be taken to reduce the defect produced by the tubbing machine. 1. Check raw material before it is received and before use. 2. Set the machine at a slow speed and first minute. 3. Replace the machine component according to the latest standard. 4. Take care cleanness. 5. Provide cover for resin glue. 6. Provide cover for ink, and the last, make sure the printing unit is clean and there are no extra material, especially on the stem. For future research, it will be better to continue this research to show that the control stage in the make stage is complete by implementation of the proposed improvement given the conduct, an evaluation and comparison with the previous condition. This is end of my presentation. Thank you for your attention.